Okay, let's get started on this practice test. Let's go through these questions. Fairly standard test. It's going to have one question for every type, but I can just reverse things. Instead of asking for acceleration, I could ask for final speed. So as long as you know your equations, you'll be okay. But let's take a look at this car. He comes from rest, and he goes up to 120 kilometers an hour and 250 meters. Okay, so let's change that. So V1 is 0, and V2 will equal 120 divided by 3.6 is 33.3 meters per second. Repeat. Probably the best equation is this one here. Okay, you could find the time it takes, take the average speed, half of that, divide it into the distance you went. That would give you the time. I'd say, how long does it take to go from 0 to 33.3? Well, you have the time. Divide by the time to give you the acceleration. Or it's the only thing missing out of here. Okay, let me solve for A. So 33.3, square that guy, divided by 250, divided by 2. We get A is 2.2 meters per second squared. Okay. Free body diagram, block, 5 kilograms sliding across the floor. Yeah, might as well put in gravity and the normal force ready because it's always going to be 5 times 9.8, so that's 49 newtons. 49 newtons. Friction is 25. I just gave it to you straight up, so that's nice. And then we need to find the applied force. How much force is forward? This thing is accelerating. So we know that F net equals MA, which is 5 times 3, is 15 newtons, which means the forward force has to be bigger than the backwards force by 15. Or F net is this force minus that has to equal 15. This guy needs to be 40 newtons. So when I go 40 minus 25, I get 15 newtons of force in the backwards direction. Okay, so that's free body diagram there. A rock is spun 55 centimeters, so that's 0.55 meters. The rock at the end is 45 grams, which equals 0.45 kilograms. And it's being spun around, and the period is 0.25 seconds. I need the tension. The tension's the only force on that rock, so that will be centripetal force. So this formula, mv squared over r, will equal to tension. But they didn't give you velocity, they gave you period, so you're going to have to go to your circle dynamics and say velocity equals the circumference divided by the time it takes to go around once, which would be 2 pi 0.55 over 0.25. It's going to give me 2 times pi times 0.55 divided by 0.25. I get 13.82 meters per second. So now we do have the velocity. We can stick this in here. This will equal 0.45, 13.82 squared, all divided by 0.55. And that number's on my screen, so I square it, times 0.045, divided by 0.55, it's 15.6. Okay, those are knowledge questions. So I could change things up, give you different length of string, change the weight of the rock, change the period. Okay, find the tension. It's just a knowledge question, so you're not going to have any up and down loops. Okay, so that page is done. Next one, soccer balls kicked 42 meters per second at an angle of 27 degrees. And they want to know the range. So these are straight memorizing questions if you want. Okay, that's called the range equation. So that would be like 42 squared. Sine of 2 times 27 is 54 divided by the gravity on Earth. And that'll give me the range. So if I go 42 squared, 54 sine times that, divided by 9.8. We get 146, 145.6, yeah, 146 meters. Maximum height, I also derived that in class, because the time to get to the maximum height would be the y component divided by 9.8, so that's v sine theta, divided by 9.8, and then we're going to multiply by the average speed, which would be just v sine theta, divided by 2. So if I just square the top, throw 2 on the bottom, you get your answer. So it's 42, 27 sine, multiply them together, square that, divide by 2, divide by 9.8, and you get 18.54. So it's like 18, I got 18.5. I must have rounded off earlier then. Okay, so we go 42 squared, 27 sine, 27 sine, square that, times 42 squared, divide by 2, divide by 9.8, 18.549, so yeah, it's a strange answer there, but okay. A block sitting on a ramp, 2.5 kilogram, the ramp's at 32 degrees. Coefficient of friction, they give you the two of them. It says draw a free body diagram of the block. So down the hill is mg sine theta, up the hill will be friction. It says it's stationary, so those two guys are going to balance each other out, and then we just have the normal force up and down, which is mg cos theta. So I really just need to calculate the one, and then we can put all these numbers in here. So let's go 2.5 times 9.8 times 32 sine gives me 12.98. Newtons of force down the hill, which means friction will be the exact same force fighting me. The normal forces are just mg cos theta. Let's get the number for that. So 2.5 times 9.8, 32 cos. I get 20.78, 20.78 newtons, which means this will be 20.78 newtons too, because the up and down are balanced. Okay, so the pulley's attached to the top, the same ramp. Okay, so we got this guy here. He's coming up here with a ramp, a pulley with a 2 kilogram block on that guy, so he'll be pulled down with 19.6 newtons. If there's no friction, it would only be the 12.98 newtons of force. It looks like it's going to go this way. So we have to figure out friction here using mu k. So the friction, we have mu k, mg cos theta, which I have up here, so I can just plug it in. So 0.3, 20.78, 0.3, 20.78 is 6.23 newtons, which is that guy. So now we have a tug of war going on. F net will equal the forward force minus the two forces fighting it. So 19.6 minus 12.98 minus 6.23 leaves me with only 0.39 newtons, barely winning. A equals F net over M, so that would be 0.39 over everything is moving, so that'll be 4.5 kilograms on the bottom there. That comes out to 0.08666, so it's 0.09 meters per second squared. Okay. Let's slide that guy out of here. Nightmare Wonderland, radius of 10, period of 5 seconds. Find the normal force when it goes vertical. So this is looping around like this. We're looking at the bottom here. The radius is 10 meters, and the period is 5 seconds. So we're going to have to change that to velocity. 2 pi r over t, so 2 pi 10 over 5. So 2 pi times 10 divided by 5 gives me 12.56. 6, so 12.57. Okay, so that's fine. Centripetal force. 75 kilogram dude, 12.57 squared over top of 10. And that's going to give me squared times 75 divided by 10. 1184 newtons. And this is the net force. Okay, that just always gives you the net force. So then if we look at the guy at the bottom here, he's going to have gravity down and a normal force from the wall. And these guys are fighting each other. So let's 75 times 9.8, 735 newtons down. And we're looking for the force up. But I know that if I take this force minus that one, it'll give me this number. So you could set up an equation if you want. F net equals normal force minus mg. We have all these numbers. 1184 equals normal force minus 735. We're going to bring the 735 to the other side. 735 plus 1184 gives me 1919. Okay, so that's what the force will be on your back. If it divided by your normal force, not normal, but everyday force, you feel 2.6 times heavier, else you could say you're pulling 2 G's. Okay. Okay, here's projectile grade 12 style, so you can expect it probably as a quadratic equation. You're shooting the golf ball up here at 22 degrees and 75 meters per second. And you got to go up 21.2 meters. Should I get Vx, Vy? We need these numbers. Vx will be 22 cos times 75. It comes out to 69.5. And that stays constant for the whole question. And the Vy would be 22 sine times 75. Comes out to 28.095, so 28.10. Okay, and that one will change with gravity. So let's just take a look at the y direction. You're just going to look at the ball go up in the air and then come back down again. Okay, so the velocity at the highest point will be 0. Velocity at the bottom will come back down again, but we just want to know, when does it land on top of here? So the ball is going to pass 21.2 on the way up, and it's going to hit 21.2 on the way back down. That's what we're looking for. The formula for finding displacement with accelerating objects is v1t plus 1/2 at squared, and you're only looking in the y direction. So let's make up positive for this case, because a lot of things are up. My initial speed's up, the displacement's up. The only one down is gravity, so I need to go 21.2 meters into the air. My initial speed is 28.1. Gravity's down, so that'll be 4.9 t squared. Half of 9.8 is 4.9. Get that into standard quadratic form. Okay, and we're going to do this. T equals minus b plus or minus b squared minus 4ac all over 2a. Might as well do that one first. So that's b squared 28.1 squared 4.9 times 21.2 times subtract square root. I get 19.34, so minus b. 28.1 plus or minus 19.34 all over 2a, which is, so that's just 9.8. Minus 9.8. So you do the two forms. So 28.1 plus that divided by 9.8. And I get 4.84. Or if I find the difference between those two, we get 0.89. Okay, the 0.89 is when it's on the way up, and the 4.84 is when it's coming back to where we want it to be, so this is the one we want to use. So finally, in the x direction, it's just VT, that's constant, so 69.5 times 4.84. 4.84 times 69.5, and we get 336.5, so, okay. That's where the ball landed. So on the test, maybe I'll make the green up here and the tee off up high and the green down below, change the signs, the directions, or maybe you're shooting from a cliff out into the ocean to try to get some pesky pirates or something. Who knows? We can just switch them around. If you try to figure it out ahead of time, that might save you a little bit of study of time. Okay, reduce effects of weightnesses. You want artificial gravity, so let's assume it's Earth. A equals 9.8 meters per second squared. So that means my centripetal acceleration has to be that much. And the normal force on the wall will make it feel just like regular gravity. Watch it. It says diameter, so that means R equals 12.5 meters. I'm looking for the period, so once I get the velocity, I'll have to go back to this formula and find T. Okay, but centripetal acceleration is V squared over R, and I need that to be 9.8 equals V squared. Radius will be 12.5. I'll solve for V. So 9.8 times 12.5, square root that, I get a speed of 11.067, 11.0679. We're we're going to use it to solve the t anyway. So I can plug that in there. So v, 11.0679 equals 2 pi 12.5 over t. Rearrange that for t, so I need to bring the t over and bring that down. So I got to go 2 times pi times 12.5, and I got to divide by 11.76, and I get 7.1 seconds. So if it goes around every 7.1 seconds, it'll feel just like gravity. Okay, one more question. Let's go through this airplane question. So, generic one is just airspeed plus wind will give me the ground speed. All vectors, but most of the airplane questions are not right angles, so we'll put it into components and add them up. They gave me ground speed, they gave me wind speed, and they're asking for airspeed, so that's going to be my ultimate question. What are the components for the airspeed? So all you need to do is change it from geography sense to components. Let's take a look at the airspeed. North, 17 degrees east. Okay, so 17, and that's 456. My angle 17 from north, but math class, you gotta come from here. So that's gonna be 73 degrees. So then the x component will be 456 cos 73. Okay, most people just know that that's cos and that's sine. Okay, so I gotta plug these in. 73 cos, 456. I get 133.32. And then we go 73 sine times 456, and I get 436.07. Okay, now let's do the wind. The wind is south, 10 degrees west. We're looking at 10 degrees there, but I need this angle. And it's 120 is the length of that vector. So this number here is 270, but it's 10 degrees short of that, so this would be 260. So that's your magic number for doing the trig. 260 cos times 120. And of course it's negative because it's in the backwards direction. And then we go 260 sine, which will also be negative because it's down, but it's going to be a bigger number because it's a lot more down than it was to the left. Times 120 gives me 118.18. And I got to find the number in here so that when I subtract 20, I'm left with 133. So you just got to go backwards. 133.32 plus 20.84. And that'll give me the 154.16. And this one will be 436.07 plus 118.18. Oh, I just subtracted. 436.07, 118.18 plus is 554.25. Okay, now be careful. Most of the questions always end it with here, and you put this back together. And I've seen people do it on a test. They'll take the ground speed, put it back together, and they magically get exactly the same answer as the ground speed. But then at least they get most of the marks for doing all this. But no, we need the airspeed, so I got to draw it out. So let's draw the big one first, and then the small one. So 554.25, 154.16. Let's find the resultant with the associated angle to it. So it's good old Pythagorean. That one's on the screen. So then we got to go 154.16 squared, add them together, square root them, and we get 575 kilometers per hour. And then we need the direction. It's mostly north with some east. We got to get the angle with tan. 154.16, 554.25, tan, and we get 15.54, so we'll say 16 degrees. Okay, you could probably, like, that's only 2 digits of accuracy, so we didn't have to type in 5 digits in each part, but I just type them all in anyway. So that's your final answer there. The only thing I could change here is instead of giving you wind and ground, I gave you the first two, you find that one. I could give you ground speed and the airspeed and say, what was the wind that day? So that's about all I can do. Any angle, any vector numbers, I can change those up, but the process would be always exactly the same. Okay.